Okay, so hello everyone. We are going to finish off what we have left yesterday, which is the integrations using the trigonometric substitutions. Okay, so we are using the trigonometric identity as in the sine squared plus cosine squared equal 1 and tangent squared plus 1 equals secant squared. Okay, so we are going to use those two. And then using substitutions, we can solve, for example, this part here. Whenever we see the x squared minus 9, okay, and then before we are conclude that we need to take the trigonometric substitutions, you can try to think with other method as well, okay? Because sometimes some integral, maybe you can just substitute like usual substitutions, or even maybe integration by parts. But for this case here, I think the best way to approach this integration is by taking the trigonometric substitutions. So what does it mean? So it means that your x is going to be substituted with the 3 secant theta. Now the question is, why I'm taking 3 and why secant? So this is how we identify. So the secant is because we have this form which has secant squared minus 1 as constant. And we see from this picture here, from the square root here, we have a constant 9. Okay? And it is in the form of squared. So that's why we take 3. So when we square it, it's become 9. So 9 secant squared minus 9. You can simply say, and we can reduce that into the tangent squared. Okay? So I hope we get that. So we can get the 9 tangent squared. Okay? So we get the 3 tangent theta. Okay? Yeah, here. And now the other case. So this is the first case. So the other case is this is case 1. Let me write case 1. And this will be case 2. So let me directly give you the question. So we have x cubed okay. Now the second case. So the second case is we have x cubed and then 9 minus x squared. It will be easy if we switch the cube and square, right? We can substitute. If we have this is x squared and this is x cubed, we can substitute this inside here and we can get the result immediately. But now the cube is here. Okay? So even if we substitute, what will we get? Okay? We're going to cancel anything, right? So this is where we are going to need the other trigonometric substitutions. Okay? In this case, what we need is we are going to take substitutions on this x, and by looking at this constant 9 minus x squared, which means we are going to take x as 3 sine or cosine. We can also take that as our alternative answer. Okay. Now remember, when we are doing this trigonometric substitutions, something that you need to remember. We are going to make a new variable, right? So don't forget to change this dx. Don't forget to change this dx. Because sometimes you substitute and then you still write dx, and then because maybe kind of you get used to that, the dx, you forgot to change to the d theta. So remember to change the variable as well. Okay? So we need to take the x into dx. We take the derivative. Okay. Now when we take this sign, when we plug into the square root, we can have 9 minus 9 sine squared. which we can compute, and then we get the cosine, right? So let's do that. So take the substitutions. So x become 3 sine theta, and then cube, and then square root of so 9 minus 9 sine squared theta, and dx becomes 3 cosine theta d theta. Okay. Now the square root, this part, this becomes 9 cosine squared. If we take square root of this, this becomes 3 cosine theta. Okay, now we can continue. So we take integrations. We write 3 sine theta cube, and this is going to be 9 cosine squared theta d theta. Okay, now we have a little bit trigonometric integral as we did yesterday. Okay. If we factorize all the factor 3, we can factorize 3 with power of 5 and then take integrations sine cube theta and cosine squared theta d theta. Okay, now we have sine cosine structure, okay, with some power. Remember the concept. Because sine and cosine, they have identity when they are squared, and we have odd, number 3 here, so we need to separate one of them. So we have sine squared, cosine squared. Okay. So we can have a good structure, and we can see which part that we need to substitute it. So let me write this as maybe here. So sine squared, cosine squared, and sine theta. And then we can change the sine squared becomes 1 minus cosine squared. Why we need to change the sine squared instead of the other one? Because the only one that not having power is the sine. So our objective is to cancel this. How to cancel is from the cosine. Okay? So that's why I'm taking it. So every process, if you're paying attention to the steps on all, at least mathematics or calculus in our class, they have reasons. They have reasons. So whenever you get into some questions, you need to convince yourself that, okay, this step is all right. I can do this because of this. If you are not knowing what you're doing, you will not get your goals. So that's key for most of the engineering questions. You need to know the reason why you are doing that by doing some method or formula. Okay? So take this, and we take the substitutions as u is cosine theta, because when we derive, this will be negative sign, which we can cancel with this other sign, right? Okay. Okay, we can maybe let me write here 3 with power of 5, and now becomes 1 minus u squared, and then because of minus, let me put minus in the front here. So minus will be here from here, from minus 1 over sine theta, and sine theta cancelled, and then the left is u squared here and du. And we kind of solve this u squared minus u4, but I will change this into u4 minus u squared and then eliminate the negative. So I will have this
as these integrations like that, or maybe that integrations. Okay. So we are going to integrate this last part here, this u. So let's integrate. So u with power of 4 becomes 1 over 5. So let's write 3 with power of 5. And then u becomes 1 over 5 here. U is cosine theta, so we can write cosine with power of 5 theta minus 1 over 3, right? And then cosine cube theta. Okay. And suppose you can write plus constant, but I will keep at the end. Okay. We still need to convert the theta into x, okay, because that is the original question. So to convert, we need to take the, let's say, the triangle here. And since our x is 3 sine theta, so we can write sine theta is x over 3. Okay, so theta is here, x is going to be here, 3 is going to be here, and the left is square 9 minus x squared. Okay, so that we can take this to approach our cosine. So cosine is square root of 9 minus x squared over 3. And now we can substitute this cosine into our equations. Okay. So 3 with power of 5, 1 over 5, and then write all here. And then with power of 5, okay, it's like a crazy number here, but I think still okay. And then we can take this 3 power of 5 and then multiply with all 3. Okay, so I will get the result as, after some cancellations, 1 over 5, 9 minus x squared, 5 over 2, minus 3, 9 minus x squared, 3 over 2, plus constant. That will be the answer. And I hope you have checked the exercise. I think some questions need to be discussed, right? Yeah. Okay. And by the way, if you already have a schedule for your final, like for other courses, let me know, okay? So that I can arrange our final exam. It was expected to be in the last week of December, probably 28 or 29. Okay, so Wednesday or Thursday. But that is depending on our progress. So, but I'm not sure if you are fine, then like in first week January, so we can, no?
You said in the beginning of the semester that it's going to be in the last week, like in the last of the
December.
16th week, right?
Yes. It depends on you.
But
I'm
you
asking.
said it's already pushed for 1 week. Because you said normally it would be in a week from the 19th to the 27th.
Yes.
And
Yes.
you said 29th, so
It depends on you actually. It depends on you. I'm checking like if you have finals, but it's okay. Like if you have final physics, for example, physics is on maybe Tuesday. You want?
This is on Monday, 19th.
Yeah. It's okay. I mean, I'm asking. This is to have like you can choose. Okay. Do you agree with that, or you want to take with the fit schedule that I'm making? Do you want to fit with that? Everyone agree? Everyone agree? So I'm looking on your agreements, okay? I don't want to have like burden for you, okay? I'm trying to help you, okay? So if you have like a really tight schedules, we can adjust, okay? It's up to you, okay? But if you will insist on taking, okay, let's have like the schedule as it is, okay? Let's do that. I have no problem. The problem is on you, okay? I have no problem. But if you want to take like as the schedule as we decide at the first beginning semester, so speak out. Please speak out. Okay.
So like for me, because normally the semester ends in that week, I would prefer to have it in the
Yeah.
week because it's normally like planned like that. And just because I know we push it back.
Yeah, it's okay. For me, no problem. But the problem is your other students. Okay. For me, it's okay. For me, no problem. Okay? I want to help you. Okay? I want to help you with your schedule. Okay. Okay. Yeah. You need to try to convince her. Okay. I have no problem. Okay, this is the case 2. Okay, case 2. Okay, case 3. We have at least 2 more cases. So case 3 is we have x squared plus 9 and then dx. So now we have a like I said in the beginning that if we look at this, it will be perfect for substitutions if we have the cube on the bottom, right? It will be perfect for substitution. But since this is the cube here and squared inside this square root, then we might get the trigonometric substitution. Okay? So we have a variable and plus a constant. Okay? Okay, so this will be, well, I can directly write this. So we can take, for this example here, that we can take the x as a tangent, okay? Or to be precise, because it has constant 9, we take 3 tangent theta. Okay. And then dx is 3 secant squared theta d theta. Okay, so if we take this, then we might to have this substitutions. And then the dx will be 3 secant squared theta d theta. And then the bottom equations perfectly become square root 9 secant squared theta. And then we can write down this, it become 3 secant theta, right? And this 3 secant theta will perfectly cancel out from this one right there. And we can write down that this will be 3 with power of maybe just 27. And then tangent cube. And then secant theta d theta. And then again, we might have trigonometric integrations, right? We have a tangent and secant. Remember, when we have an odd number here, odd power, so this is 3, this is 1, right? What we might need is we need to separate these equations and make secant theta, okay? Make secant theta. So we can rewrite this, and we can change the tangent squared becomes secant squared minus 1, and we can have perfectly cancellations. We can have u substitutions for secant. Okay. So if we take u for secant, we can cancel this, and this is perfectly becomes secant tangent. Okay. Okay, so this is become u squared minus 1, and the secant tangent is cancelled, so this is just this u squared minus 1. So we might need 1/3 secant cube theta minus secant theta. Okay, and again we need to convert back to the original equations, okay, to the original variable. So we have x is 3 tangent theta, right? So we have tangent theta is x over 3. So this is x, this is theta, x over 3, like that. And all the way here, the hypotenuse is x squared plus 9. So the secant, so we write here, secant theta is square root of x squared plus 9 divided by 3. So let's change all of them. It should be 1/3. So we have 1/3. If you want to complete this, that's the final answer.
No, I think it's
3, right? 3, right?
no 3 in the first one.
The first one,
Yeah.
27.
It's
Oh, no, it's not squared. It's not squared here. Wait, not squared here. And then this one is correct, right? The left one. This one is 9, and then this is half.
But 1/3 is actually 3. Because it's 27/9.
No, it's over 27. Because it's cube.
Ah, okay.
Cube, yeah, cube.
Yeah.
That's why we don't see.
Okay, now the other example related to this trigonometric substitutions is if we have like this problem here, integration of x over and then square root 3 minus 2x minus x squared dx. So I'm not sure whether we can solve with any methods. Yeah, I think the only way is we are going to substitute with the trigonometry. The idea is this part here we're going to rearrange. And make it more convincing to be substituted with the trigonometric part. so the idea is, because this is quadratic equations, so perhaps we are going to have like a complete square. Let's try to complete this the equations. So perhaps we can see, maybe let me write here. We can write this as, probably start from this part, plus 2x. And then we can complete the square by taking this 2x by plus 1 like that. And because we plus this 1, we need to also Well, it's actually minus. Okay. Well, it's actually minus 1, so plus 1, right? So plus 1 here. Okay. So we are going to have 4 minus x plus 1 squared. Okay. So this is, if you get this from your process, okay, it's a good sign. Okay, this is a good sign. So if we could rewrite the form, let me write. So this is still x, and this is 4 minus x plus 1. Still, we need to do something here, right? So the best way to look at is, if you want to make an ideal trigonometric substitutions, the x plus 1 need to be in one variable. So let's just make that happen. So let this becomes u. Okay. So that we are going to change all into variable u. So u is equal to x plus 1. So x is u minus 1. And du is dx. Okay, if we derive. So we could take that and write this u minus 1. And then we could have this 4 minus u squared like that. And we can simplify the forms at the beginning, and it's more more convincing to be substituted by the trigonometry, right? We can substitute the u with the sine, right, or cosine. So if you take this as a 2 sine theta, because it has 4 constant, and du is 2 cosine theta, and this part is become 4 minus 4 sine squared, which is goes to 4 cosine squared, and we take the square root and becomes 2 cosine theta. So this will be, let me write here, 2 sine theta minus 1 over 2 cosine theta, and then du is 2 cosine theta d theta. And we can cancel this, and yeah, it's become more simplified, and we can integrate directly. This will be negative 2 cosine theta minus theta. And again, we need to take the triangle. Let me write here triangle. So 2 sine theta, so sine theta is u over 2. So u 2, so this will be 4 minus u squared. So we change theta to u and then u to x. Okay, so we have more to come. So this will be cosine theta is cosine theta is square root of 4 minus u squared over 2. But then it's multiplied by 2, so it's going to be negative square root 4 minus u squared. And the theta, we can just using the inverse, sine inverse of u over 2. Okay. Still not yet finished. We are going to take u is x plus 1. So this is going to be the original equations at the beginning, right? and plus constant. Okay, I hope you get everything correct. I'm writing a little bit messy here, sorry. Let me resize this. Let me resize everything that can be resized. Okay. Yeah, quite challenging, especially the way you need to identify this part here. You're going to have having a complete square, and from this part, you take this into our solutions for trigonometry. It takes time, for sure. It takes time. And it takes time for you to practice and familiarize. Yeah. For me as well. It takes time for me as well. Okay, so I think that's all for the trigonometric substitutions. So before break, perhaps a little bit introduction for the next part, for the next method. It's a little bit introduction. And I may include maybe next week, or maybe maybe next week for exercise on chapter 7. So you have exercise on 5, 6, and maybe next week's exercise on chapter 7. Just to confirming your understanding in all the methods, because derivatives has several methods, but integration will be having more methods because it's not direct approach. Because in derivative you can think like you are deriving something so that can predict what happened. But for integration, because you are going backwards, you can have many ways, right? And you can have many solutions, right? Okay, just a little bit introduction. We call the partial fractions. Okay. Okay. So as the name suggests, what partial fractions means is you have a structure. That you need to integrate. The idea of the partial fractions is to separate those big fractions into small fractions. That's the idea. So maybe let me begin with some computations. For example, if you have 2 over x minus 1, just a simple calculation here. Okay, we know that this can be written. We can multiply the denominator, and we could write x squared minus or plus x minus 2. And we could write the top is 2x plus 2 and then minus x minus 1, right? And if we compute, we can have is x plus 5 and then x squared plus x minus 2. Now, if the question in integrations, if they are asking like integral of x plus 5, x squared plus x minus 2 dx. Right?
So this seems to be like really complicated because we are going to maybe take substitution and make the teachers work. We take integration by parts, but we are getting confused which one to take into the parts, right? But if we take this and make it into these two small fractions, and we integrate each one, it will be better, right? It will be better. So the partial fraction is basically just a reverse of your, or like a normal computation in a fraction. So you reverse that process and make it separate. Okay?
Makes the big fractions separate into small fractions. So how to do that is basically we're going to take this, because we can factorize this part. We can factorize become x minus 1, x plus 2. So the first thing we need to do is imagine that we are going to take this, or maybe let me erase the integrations first, okay, so that we can focus on the fractions. So let me write here, make it two small fractions that has denominator x minus 1 and x plus 2. And then taking a constant a and b on the top equation, or the numerator. Okay. So what we are going to do is, first,
we are going to write some equation that can be computed for a and b. So for example, we first start from x minus 1 multiplied with x plus 2, it's becoming this, right? And then we put this divided by x minus 1, it's x plus 2, right? And we need to multiply a. So that's going to be in this equation, actually, right?
so we could write down, so I hope you get my point, okay? So the point is, this x plus 5 will be equal to a x plus 2 plus b x minus 1, okay? There are several ways to solve this.
I think this is just a simple equation. First of all, what we need to do is we need to equaling the left side equation or right side equation. So we need to equal them. So we need to equal which one has a group of x from this part. This is only one, right? Only one. So this has ax plus bx, right? So a plus b. So a plus b need to be equal 1. So it's like system of linear equations. It's like normal linear equations. That's the first method. The second method is we can take x, maybe take x negative 2 to make it to 0. And then negative 2 here, and we can compute b, negative 2 here, we can compute 2.
So let's try. So let's try both methods, okay? So first, you can try to take this So we can take this a plus b is equal 1 and 2a minus b is equal 5. So if we plus this, we have 3a equals 6, a equal 2, and b is negative 1. Or let me give you an alternative approach that I think may be better. We can let x maybe first is equal 1, so that all the b part will be 0, right? So we can take that. So we have 6 equal a 3. So a is same, equal 2. And let the other part, x is equal negative 2. So negative 2 is negative 3 equal negative 3 Is it correct? X equal negative 2. Oh, this is, yeah, this is b. So b is negative 1. Okay. Any method is okay, as long as it solves the system of linear equations. Okay? I hope you understand the system of linear equation. Okay, we will have a break. Okay. Okay, so first, is there any part of the question in the exercise that needs to be discussed, like the real priority? Okay. I have some suggestions, but if you have from your side, we can discuss that. I think for area and volume, is there any problem with that? Or maybe some specific problems for area volume? Like the taking just the disk method or the cylindrical method. I think as long as you identify, you can get, right? Or maybe you're still confused about that. Maybe we start with the, I think, let me write maybe.
Will you ask the area of the volume? The volume.
Mm-hmm. Yeah. You mean the which part?
Like,
Within the surface area?
yeah.
Yeah, I think it's from the cylindrical shell, the shell method. Like this one. Did this one you ask, or is still confused about this? Or it's already okay? Okay. I think it's okay if you already know. Okay, let me start with this. Okay, let me start with this. I think in some parts of the questions, I'm writing the integrations, and I think one of the students also asking me this part, right? X with power of 8 and plus x. Anyone solve? Anyone? This one? Yeah, let me give you a couple of minutes to think first. The clue is using substitution. Substitution method. You can check using the wall from our, yeah, you can check that. At least to confirm the final answer. Yeah. It's using substitution, but the way you substitute is a little bit different than we have done before. If you remember partial fraction that we discussed as an introduction, well, we took partial fraction, but we still have a long way to go because it has. If we factor out x, we have still x to the power of 7, which is not easy to be calculated. So, okay, so no one solved this. If you check in the website, what is the answer? I think you can use integral. that's one way that I want to describe. Are you still confused, right? Why? Okay, let me explain. But the explanation is already correct. But let me rephrase in more comfortable way here. Okay. So you see this. You have like the really high power, like I8, and you can think like 9, 10, 11. The trick will do the same. Okay. Plus this is just x. When we deal with this, our instinct intuitively says, okay, factor out x. And then we have x to the power of 7, right? Okay. But instead of that, please factor out the highest power. Okay? Try that one. So try to factor out the highest power. So this will be x with power of 8, and then we have 1 plus, this will be minus, right? Okay?
Still seems weird, but let's continue. Let's continue. X to the power of 8. Let's move up here. And what will it be?
Minus, right? Minus 8. So it will be x with power of negative 8. So some, I think that is still okay, right?
And I think not many people are comfortable with the negative, right? When we are working with something. But actually we can do that. We can do that in math. Okay. So look at this. Minus 8, minus 7. What we can do. Substitution. Which part? X. Okay, remember, if we take the negative, imagine we differentiate. Yes. Because if we take the negative, if we derive, it will have minus 1. So if we take this, it will be negative 8, and we can cancel.
Okay, so that's what we are going to do. So take the u as 1 plus x with, or this is what you are dealing with this website, 1 over x power of 7. Okay? So I'm writing with the negative so we have more comfortable in understanding. Okay? So we take the du, and this will be negative 7 x negative 8 dx. So dx is so we can take this into our solutions, and this is practically just 1 over u. And this will be ln. U is 1 plus 1 over x 7.
Okay? Okay, another question that I want to discuss is, so I forgot the question. Can you read the question? Let me. Number 7, can you solve number 7?
I tried to, this one.
This is three.
So it's this is f, right?
F or G. Okay, F. So F the left one.
Okay. So f is having, this is 1 plus t squared
Yeah.
dt. This is f, right? And g is from 3 to y. And what is the inside?
f of x dx. F of x dx.
Okay, then the question is finding the g prime pi over 6. Okay, anyone solve this?
I think number 7. Number 7. We're happy to track. We immediately give up. But that's okay. This is, I think, if you're not careful enough, maybe a little bit difficult. But remember, the original default equations for the this is fundamental theorem of calculus. So the original default of the equations is, it's not 0, it's not constant, it's just a constant a. So it can be any constant. So when we derive this and derive this constant doesn't really mean anything. Okay, I think we proved that when we prove with any constant, the result's still the same.
The original equations, to remember, is that we have f of, let's say f of x or maybe, let me just take this f. Okay, this is not 0, this is a, this is f of t dt. Okay. So f prime, this is just f of x. Okay. This is what we call the fundamental theorem of calculus.
So this is the fundamental part. So basically we are just substituting the x into t. And then multiply, don't forget to multiply with the chain rule of this x. So if this is 2x, then we need to multiply with 2. So we need to take this g double prime, then we need to derive this g twice. So if we derive this,
Then this is going to be g prime y is fy, right? And y and x is not
defined as a function of each other, right? So it's just a normal variable. So it can be any variable. So if we take one more derivative,
so we take derivative out of this. So we take f prime y. So what's happening here is
we are going to take f, derive one time, and then plug in pi over 6. So let's
try to do that. So we take f prime x, and the equations become 1 plus sine squared x, okay? And don't forget the chain rule. So sine x is derived become cosine x, and that's it, okay? So g double prime pi over x pi over 6 is equal f prime pi over 6, and this will be 1 plus sine pi over 6 squared and cosine pi over 6. Sine pi over 6 is half, so it's 1 over 4. So it's square root of 5 over 4. And cosine pi over 6 is square root of 3 over 2. Or we could take this as square root of 15 over 4. Okay.
And so, because this part here, the fundamental theorem of calculus, it will link between derivative and integral. So all the things in the derivative probably will be asked also in this kind of question. like concavity, increasing, decreasing, as I think one question also asking that. Also, like limit, for example, the L'Hopital rule, but the limit is in the form of integration. But that's actually the same thing with the L'Hopital rule, but the difference is it has the integral. Yeah. So that's why, even though I said that at the, I think in class, the first half will be derivative, core concept of derivative. The second half is integration. But integration, we cannot really unlink from the derivative for the at least one chapter, 5.3, one section, 5.3. This fundamental theorem of calculus. So we are still all needing the derivative concept. I think this is okay, right? How about number 10? Over here, yeah, from here. Not really. This is limit is okay, right? Oh, okay. Number 10, right? This is
Okay. Another question is number 10 in your homework. I think this is 0, 1, fx dx equal 4 or 2, 4, right? And then what's the question?
integrations from 0, 1, 1 minus x.
And then it has f x squared. What?
X squared minus 2x plus 1.
Yeah, this is also challenging.
This is also challenging. So first we are given this information. And perhaps this is for the last computation. But the question is, we are looking at this 1 minus x, and then move it with f. And inside this function, it's having the quadratic x squared minus 2x plus 1. So what's your instinct tells you? What should you do? Run away. Run away. Oh. So here's the tips. In our method, remember that we can substitute many variables with other variables, right? Like in the substitution. Why don't we try the same thing, right? I think if we look at this quadratic, it's interesting, right? We can factor. Can we factor? Okay, let's try to factor.
Squared, right?
Okay. I think if we look at the inside of the bracket, this 1 minus x is just a negative form of this x minus 1, right? Let me try something. Let me give you a couple of minutes to think from this. Yeah, try.
The square is
Yeah. Yeah, substitute. The idea is substitute. So the substitution for this type of question, after we rearrange this part, the sum substitution, our goal is to make this equation link up with this. So our goal is to make cancellation with this. So it's going to be fx or other variable that you write here.
I think this is
This 2 is, I think, final exam from maybe 1 or 2 years. I think 2 years ago. 1 the exam.
So take u, for example, x minus 1, let's say squared. So du will be 2 x minus 1, okay, and dx. So dx is 1 over 2 x minus 1 du. And then don't forget that we have 0, 1 as the endpoints. That is still in x. So probably we need to take that and change the endpoints. So when x is 0, u is 1. When x is 1, u is 0. So this will be 1 to 0, 1 minus x, and then this will be canceling with this 2x minus 1, and then this will be f u du. We can cancel this and make it negative, make it negative like that. So we are having negative 1 over 2 integration 0, 1 f u du. But I can switch the 1 and 0 and make it positive, right? So this is equal to half, and we are back again to 0, 1 f u du. And since we have this informations that fx dx, when we integrate from 0 to 1 is equal 4, then this will be just 4 divided by 2, so it's 2. Okay.
So this is also my consideration. Since your midterm, the average is not really good, so I am going to consider some of the questions. Oh, by the way, you can check if you are having the makeup exam. I have bring back the results. Most you getting higher. Some getting higher really high. Some just maybe a little bit, but still okay, higher.
But I think it's good. Okay, it's good. Okay, so let's try one more from your exercise. I think this is, one of the hardest. This one. Okay. I think this is number 10 or 9.
Okay. The last one, or yeah, the last one, number 19. Yeah. The last one.
So let me make it a little bit smaller here.
So the idea, okay, we need to set this two area, A and B, with all the curves that included, that they are equal. So A is equal to B. The question is asking the curve C. So we know the green one is x squared, the red one is 2x squared. The very first thing we are going to do is we are going to set the integrations and make these two areas equal. So we set the integration for A is equal to integration of B. So we set up that way.
So first, if you look at the B, we are going to set the integrations by taking this y equal to x squared as the top or as the right side of the area. So we are going to take this and minus the curve c. So we are going to change into variable y. So it's going to be dy. So we need to write this as x. So x squared is y over 2, or x is square root of y over 2. So, and we are going to just need the positive one because we are dealing with just the positive axis, right? Okay. So that's the red curve. Okay. And minus the curve c. So we just write c with maybe variable y. And then to make it complete, we set some constant for this point P. Let's say the constant may be A or C or any variable. And A is actually one of the key. We need to find the A. So first, since we are going to take y, so this is from 0 to a squared, right? So P is, we can write this one, is a to a squared, okay? And then this will be square root of y over 2 and minus c, that is function of y, and then dy. So this will be the B. Or maybe let me write with red color. Okay. And this should be equal with the A. And A and what is A? So it should be, yes. Maybe let me write A maybe around here. Maybe different color to make it clear. So maybe blue. So this is just a normal dx. So from 0 to A, right? 2x squared minus x squared. So this is just x squared. And this will be 1 over 3 x cubed, but we can directly substitute x with a, so a cubed. Okay, now, okay, we are going to equaling this b with this a, but let me simplify this first. Let me solve the left one here, because I think we can solve that. So the squared y over 2, we can write as 1 over 2 like that, and then we can integrate this, right? So to summarize, let me just write the final result here. 4 over 3, and then y over 2, and then 3 over 2. And this is from 0 to 2a squared. And minus the c. So 2a squared cy dy. And then we can still solve this first. So take 2a squared inside. So it will be 2a cubed, right? And 2 by 2 is 1, so 4 over 3. So 4 over 3 a cubed. And then we still have the c minus integrations right? Okay, I think we can just equaling this to this part here. Okay. So we are going to equaling this 1 over 3a cubed with this. So we are going to move out this here. So we will have negative a cubed, but it's all negative, so we can multiply with the positive. So a cubed is equal and how to solve this? Now we have this. How to solve this? Remember the previous two questions before?
Yeah,
The fundamental theorem of calculus.
yeah.
So
So,
we take the derivative of to remove this integration, right? So we take the derivative of a. Okay. So this will be 3a squared, and then c 2a squared, and then multiply with the chain rule for a. And c so we can solve this. Can cancel the a here, cancel here. So c 2a squared is equal 3 over 4a. So remember that if we have y is equal to a squared, so then we can write cy 3 over 4 square root of y over 2.
I don't know what's wrong with me.
So when y is 2a squared, if you remember, the x is just a, right? So it's actually the x is equal 3 over 4 and then we can take squared. So x squared equal 9 over 16 y over 2, and we can have y is 32 over 9 x squared. Yes, what shall I do? Yeah. You really take time.
If you know what you're doing.
But even though we know, perhaps to link this part to here is, I think, a little bit difficult.
Like the second part, still. What?
You just integrate, make use of y having 1/2. Yeah. Yeah, you can ignore the 2, which is faster. It's over 2. Half plus 1 is over 2, so around 3.
I would have stopped in this part. Like CY equals 3, 4. Yeah. Because I didn't know where to consider for the line. That's you could stop there on the second step. No, the first step.
Okay, because we are running out of time, I think we need to do some feedback first, okay? So if you have any more questions, we can do after that. Some 6, a little bit 7.
It doesn't matter, because my brain right now is not. Are you unifying, I guess, all the answers?
I hope there will be answers that you can, problems where you can request, where you have to type it. One could.
I need the multiple choice. Otherwise,
But you don't know the same.
write 0. Actually, you want to write 0 here.
Okay, I think ready? Okay, number 1. Okay, Okay, use your student ID. Let's try. Start.
Yeah, it's short function. But the idea is just to find which one is higher.
Okay, the y equal x is higher, right? Okay, okay. Okay. Okay, good. Okay, next one. Number 2. Let's try. Yeah, 4 minutes.
It's supposed to be, I think, it's supposed to be. So don't forget to find the intersections, and then which one is the highest, and then you can arrange the integration in this area. Okay, is using calculator helpful for your exam?
Yes.
Probably I'll allow for the final. Okay.
To verify quickly
Okay.
the graph. Because I'm doing like this. 就是那你就不用管了，其他的就是电球，
觉得我该出去好好的一次，我觉得我呼吸无所谓，或许我相信你哦，不要让我失望哦。
Okay. 72.
你数学是不错哦，之后我可能会常常问你问题。
Oh, I give up.
哎，AB 上榜了有没有？
Who?
有没有看到？
Okay, okay. Appreciate that. Okay, last one. This is going a little bit trigonometric.
Giving you almost 5 minutes. You can solve with whichever you like. Maybe identity. So you divide it up.
You work with this identity.
Okay.
Okay, still the winner. Okay, congratulations. Okay, so the attendance.
This one give you sign.
Okay, if you finish, then we are done for today's class.
So when you integrate, then you get at the end you get x over 8 minus you get x over 8
Yes, yes.